Hey guys, this is JSer. In this video, let's take a look at 5449. Check if array pairs are divisible by k. Given an array of integers and even length n and an integer k, we want to divide the array into exact these pairs such that compare them such that sum of each pair is divisible by k. Return true if you can find a way to do that, or false otherwise. So for 1 to 9 and k, the pairs was 1, 9 to a 5, 10. I see. And this would be 1, 6 to 5, 3, 4. Yeah, this is 1. No, for divide by 10, it means 4, 6, and nothing, right? This, okay, cool. So let's take an example like this. Attention that there's negative numbers. So for a bunch of numbers, if we're going to say 2 numbers adds up to a multiply of k, it must be what? Like a plus b and mod by k should be 0, right? And that means that the mod of themselves, the sum of mod of themselves should be multiply of k, right? Something like this, plus b mod by k, and then mod by k should be 0. So maybe we could try to find each modulo of numbers, right? Each number's modulo. Like for this, the module would be for like the case 5, and it should be 1, 2, 3, 4, 0, 0, 1, 2, 3, 4. So we could loop through all the numbers, and we found 1. There will be no negative in this module. If there's negative numbers, say like -1, we will append it to make it 4, right? Okay, so we actually are going to find what? Find the corresponding modulo, right? If we have 1, we need to count if there's 4. So we got a pair, and we can, there's multiple 4. Okay, 3, 4. Okay, we remove this pair, and then we got 2. We need to find 3, remove this pair, and got 3, 2. So actually, it's about, we see that it's actually about the count of each number's modulo. Am I getting right? Maybe not. Okay, anyway, and then find the pairs by direct access, right? It's used by set. A map, actually. Map. So that's it. At last, if no single element left, then okay, right? So obviously we need a map with modulo this. Oh, maybe I misspelled. I'm sorry. And the count, right? Cool. Let's do it. So count map. Create a new map. And for each number, we will count the module. But here this problem, if negative, we need to plus the k. Equals num. If it is negative, we num plus k, right? If not, then num itself. It should be mod by k. Yeah, and then we will count it, right? So if count map has this mod, then count map set mod to increment. If not, then set mod to 1. Right? And then we start counting. Remove the pairs. So we will loop through let mod count of count map. So the counterpart should be k subtracted with mod, right? So actually it should be the same actually. If count map get counterpart is not to count, then it means not match. Return false. And if matched, we need to delete them, both of them, right? So count map delete mod, count map delete counterpart. That's it. And if everything goes well, it will return. Wait a minute. If there is 0, if it's 0 itself, no, yeah. If it's 0, because they're always even numbers, right? If you have 2 zeros, if this 0, we're going to search for 5. There's nothing. So there's a problem here. If mod is 0, we continue, right? We not continue. We need to handle it differently. Let's see. If mod is 0, then and the count. Okay, if mod is 0, if count equals is not even, we return false, right? And so when it's okay, we delete it. And for the other cases, we need to find the counterpart. Okay, this should be good. And then return true. Let's analyze our code before we try. For a case like this, what will happen? Okay, first we get the mod is 5, 4, 4, 3. Okay, for 1, 3, 2, 2, 3, 1, 4. Right? We got 1, 2, 1, 2, 2, 2, 3, 2, 4. And when we count it, and here's the counterpart 1, 4, 1, 4. It's the same. If not the same, shit. If not the same, return false. And they are same, we delete mod, and delete. Okay, looks good. Let's run the code. True, true, false, true, false. True, true, false, true, false. True. At last we got false. Last one. Really? We're going to get k is 3, right? Okay, 3. Okay, is 2. 1, 1, 2, 0, 0, 0. It's negative for this. I see. So there might be something plus k is not enough. Then I think you should change it to positive 4. This is actually 1, right? Oh no, this should be the mod of minus 4 should be, this should be 1, so this should be 2. So get transfer positive, and then positive, and then get to the mod, and then get subtraction from the k. Okay, so the counterpart, the mod is not like this. Okay, so if num is bigger than 0, then num mod by k. If not, it should be the positive one mod by k, right? Positive one mod by k, and k subtract with that. True, true, false, true, true. True, true, false, true, true. Looks good. Let's submit. I didn't log anything, right? Any irregular cases? N, all positive, n is even, looks good. We got wrong answer. What? Huh. Let's see the example. 3 should be return true, but we return false. So let's just take a look at the last one. Yeah. Let's just log the count map. Console log count map. 2, 4, 0, 1, 1, 4, 3, 1. We're going to get 3. Ah, God. I made a mistake. That's there should be no 3 here, but this actually gets a 3. If it's 0, right? Let's log the count. Stupid as me. So this is 2. Minus 4. Mod by 3. Minus 1. Okay, we got the mod for 3 is 2. Obviously it's wrong. So negative numbers, if there is 1, divisible, right? Okay, so 2 actually is right, because when we get 1, it gotta be minus 3, so it's okay actually. And then this is the same. 2 and 2, yeah, 2, 0 and 1. This is 1, 1, 1. Wait a minute, this got 1? No, this is not 1 actually. 1 is minus 7, so it cannot be divided by 3. That's still stupid. We get to the opposite part. It's counterpart. It's 8. It means 8. The mod for 8 is 2. So actually, this should be 1. Yeah. Yeah, this is 1. 1 plus 2 equals minus 6, yeah. And then got minus 3. Minus 3, the counterpart is 3. So this 0, 0's counterpart, it should be 0, right? I made a mistake. And this should be, it might be k itself, so we mod k again. Shit. Yeah, so, okay, that's it. Accept it. Cool, so that's all for this one. Hope it helps. Okay, see you next time.